Chapter 3, let us get to the next problem. Number 17, the last one, page 78. You have seen that the math library contains a function that computes the square root of numbers. In this exercise, you're to write your own algorithm for computing square roots. One way to solve this problem is to use a guess and check approach. You first guess what the square root might be, and then see how close your guess is. You can use this information to make another guess, and continue guessing until you have found the square root or a close approximation to it. One particularly good way of making guesses is to use Newton's method. Suppose x is the number we want the root of, and guess is the current guessed answer. The guess can be improved by using guess plus x over guess, all divided by 2, as the next guess. Write a program that implements Newton's method. Okay, the program should prompt the user for the value to find the square root of x and the number of times to improve the guess. Starting with a guess value of x over 2, your program should loop the specified number of times, applying Newton's method, and report the final value of guess. You should also subtract your estimate from the value of math.square-root, math.square-root of x, to show how close it is. Okay, so math.square-root being the function. Yeah, so let's get this started. So that's a couple questions ago. I actually did change that. I think we got a negative number, so I changed it to absolute value. I took the absolute value of the answer, which ultimately was like negative 0.0000245, something like that. So I took the absolute value, which gave us a positive number. So that was from before. Okay, so now let us write this. So the important formula is going to be guess plus x over guess. And that's all over 2. And that is Newton's method. Okay, so let's call this Newton. Pi. So this program uses Newton's method to find a close approximation of square root of a number. And then the number of times the program will arrive at a guess, an updated guess. All right, so all right, set that up. All right, so it's going to be, so we're going to put in the number and the number of guesses. So we're going to have num and then guesses. So out here, we'll call it a number, and then guess num. And then we'll go a number and then guess num. So let's do int input. Please type a number that you wish to find the square root of. And then please type the number of tries, no, the number of times that you want to run your number through, let's just call it Newton's method. All right, so we call that. Okay, then we're going to print it because we want to make sure that we get an output to the console. Okay, so we'll do a for loop for x in range to guesses. We'll do 1, start at 1, and then guesses plus 1. Because you want to include the number of guesses. Start, stop, step, and then for the step, it's going to be, we don't need that last argument because step's going to be 1, so that's the default. So for x in range, do something. Do take the number let's put we'll do num because guesses is the quantity of guesses. I don't want to use the word guess to talk about the actual number, so because I think it'll get confusing. So we'll just call this num. This is the number that we're running through Newton's method to get to a close approximation. So num equals num plus let's see plus number slash num. And then I put that up there on purpose right here, that parenthesis. So we'll do that. We'll do this. So num plus number over num. So number over num I'm going to solve first because that's the order of operations, so we don't need a parenthesis there. I'm going to add num. That parenthesis means do all that first and then divide that by 2. Double check here. Yep. Top numerator is solved, and then divide that whole thing by 2. Okay, cool. So num equals, all right, so then we don't need to initialize number or guesses because they were already passed in those parameters as arguments in the def in the newt header. I think that's good. And then we're going to return newt num. So this here, these are the arguments that get passed through into this function. And this is what's returned. So we want to print the return of this. I think this is going to be decent. I'm not positive. I feel like I might be missing something in that function there, but it seems right. Guesses we're not going to actually use. We're actually just using that as our range, as like the number of tries. It's not actually going to be a number that's being used. So let's try it. Okay, so let's do 4. Let's do 100. Oh, I knew there was going to be a little hiccup. I don't know why. Okay, so reference before assignment. Oh, of course, I knew it. Yes, so I knew there was something that was like gnawing at me. Okay, so newt num equals 0. No, we can't do that. Because we use newt num down there in the denominator. So you gotta initialize newt num. And you have to make sure that we don't, we're not just gonna pick random numbers willy-nilly like 0, 1. So I wonder what newt num starts at. I mean, I guess I could do all this longhand and see where we're at, but let's do so if it was 0, it wouldn't work because 0's in the denominator. It would throw an error right here. If it was 1, I don't know if that would work because it's going to be 1 plus number over 1. The number over 1 works fine, but we're adding 1 now. Could look it up. Okay. Might be the method. Just looking it up. All right. I mean, I guess I could. Let's just start out doing this. We'll look it up in a second, but I wanna try to see just what it looks like. Just going through, starting it at 0. I bet you it's an error at 0. Pretty sure. Or what if? Yeah. Yeah. Let's print it first. Well, it wouldn't matter because it's going to be 0, and then, yeah, it's not going to matter because the first one's going to be 0. Yeah, exactly. Okay, cool. All right, let's do 1. I'm gonna try a couple of things. 0, 1, and I'm gonna pick a tiny decimal, like 0.000001. And again, I'm not a math guy, so I might be walking into a buzzsaw, you know, but you know, I'm not terrible in math. I just didn't, you know, major in it or minor in it or anything. So I think being more mathy, you know, is obviously a lot more. There's just a lot more, since there's a lot more logic involved, and you've just, you know, I spent a lot of time with numbers, but not nearly as much as probably a math major. All right, so let's do this. Yeah, it worked. Boom. Let's kill it. All right, so we'll. I mean, I'm sure the math majors already knew this, that um we initialize it at 1. So even though it's you know, it's 1 plus this, I think that's what it is. I think it's supposed to be initialized at 1. We could have looked it up, but it's good practice. Like looked it up on Google or on Stack Overflow or something, and we probably would have gotten, you know, someone on there would have on one of those sites would have probably made it really clear and obvious. But yeah, we figured it out. Okay, so let's save this. Let's run it. All right. Let's do 121. And let's just run it once. Okay. 121. Let's run it twice. Getting closer. All right. 121. Let's run it 100 times. Wow. 1, 2, 3, 4, 5. Like once you get to the 5th time, you're real close. But it keeps running. Okay, so it just runs 100 times though. All right, so now let's delete this. Save it. Run it. Let's find the square root of 169. 5 times. Bang, look at that. Beautiful. Beautiful, beautiful. Let's pick some huge number. Boom. So then let's do it. Let's do 58,420 times 58,420. 3,4,1,2,9. Very close. 3.4 million. 3.4 million. 3,412,000. Yeah, real close. Real close. That's kind of cool. All right, so let's check that out. Number guesses. Okay, so we initialized num at 1. Obviously, division by 0. We knew that was going to be a mistake, but we tried it. And then the other route would have been if 0 or 1 didn't work, then I would have thought that some tiny decimal would have worked. But I was more hopeful about 1 because obviously this changes this whole number. You know, when you're dividing by a number, dividing by a tiny little decimal is like multiplying by a massive number, right? So that I knew that would have probably been wrong, but because like let's say you divide by 100th, like so 0.01. That's going to be dividing by 1 over 100 which multiplies by the reciprocal, right? Which multiplies by 100. So it's going to multiply by some massive number if it's going to be like 0.00000001. So I knew that was wrong too. The only route would have been 1, because 0 wouldn't have worked the division by 0 error that we knew would get thrown off. And then and those are the only ones I would think of. There's no reason for a negative. That doesn't even make sense, because we were adding num and dividing it in the same, in the same parenthesis here, and then dividing that by 2. So I was hoping it was 1. And then if those didn't work, then I would have probably looked stuff up, or talked to an expert, someone that's got a lot more experience with math and Python and this specific problem, etc. Or the teacher. I mean, there's a lot of routes I would have taken. But yeah, I'm glad this ended up working well with num being able to be initialized at 1. All right, guys, cool. Thanks a lot.